All right, we're going to go over the practice test. I thought maybe I'd record a video so I can go through and explain things a little bit better than just work. So you're welcome to skip ahead or pause or whatever you need to get to the problems you need to get help with. I'm just going to go through and start with number 1. So the endpoints of a diameter of a circle are -7, -3, and 9, 13. We want to write the equation of this circle. So the first thing you want to do is you want to find the center of the circle. If you're given the endpoints of a diameter, the center of the circle is going to be the midpoint. So, if 9, 13 is over up here, so -7, -3 is down over here, then the center, that's our h and k, that's going to be the midpoint. So to get the midpoint, you're going to use the midpoint formula, which is x1 plus x2 divided by 2. So we'll say -7 plus 9 over 2. And for the y's, -3 plus 13 over 2. That gives us, of course, 2 over 2, which is 1, and 10 over 2, which is 5. And there's your center. To get the radius is the distance between one of the points and the center. So the radius, if you use the distance formula, is the square root of, since our center is 1, 5, we can say 9 minus 1 squared plus parentheses 13 minus 5 squared. And if you work that out, that's going to give you the square root of 8 squared plus 13 minus 5 is also 8 squared. And that's 64. So 64 plus 64 is 128. So there's your radius. There's your center. Now it says to write the equation of the circle. Notice it doesn't say in standard form or in general form. So when it doesn't specify, I usually just say standard form. And so remember, the equation for a circle in standard form is x minus h squared plus y minus k squared equals the radius squared. So since I have my h and k, which with both happen to be positive here, they're going to go in here and switch to negative because of the subtraction signs. And the radius squared is going to be the square root of 128 squared, which is 128. So your final answer will be x minus 1 squared plus y minus 5 squared. And the square root of 128 squared is 128. That's your equation. Okay, moving on to question 2. It says write the equation of the circle shown in the graph. Again, it doesn't specify how, so we're going to write that in standard form as well. This is much easier because we don't have to worry about calculating the center and the radius. We can actually use the graph to get that. So the coordinates for the center, that coordinate is -1, +2. And the radius from the center to the edge of the circle, that's 1, 2, 3 units. So since the radius is 3 and your center, your HK is -1, 2, then your equation is going to be x minus -1 squared plus y minus 2 squared equals 3 squared equals r squared. And so it'll be x plus 1 squared plus y minus 2 squared equals 9. Okay, that was question 2. Let's move on to question 3. Question 3 says in the circle with center O, what is the measure of angle x? Angle x is up here. Before we can get angle x, we have to be able to figure out what the other angles in that triangle are. So I look at that 140. That's a central angle. In a circle, the central angle is going to be the same measure as the arc it intercepts. So that arc over here is going to be 140 as well. Now the rest of that picture, really what matters is down here. if you draw the angle that comes from that arc, or we say subtends that arc, the angle that goes all the way to the edge of the circle, that's going to be an inscribed angle. And those are always going to be half of the arc. Well, my arc is 140, so that angle is going to be half of 140, which is going to be 70. Now I'm not done, but I can write 70 down here in that angle. Notice that these two segments are marked congruent. Well, that's an isosceles triangle, so I can assume that y is going to be 70 degrees as well. And in any triangle, of course, all the three angles add to 180. So I'm going to go ahead and do that quick math. That's going to be 70 and 70. X is what we're trying to find. Well, 70 plus 70 is 140, so x is going to be 40. So the measure of angle x is 40 degrees. All right, let's look at number 4. If 3x squared plus 6x plus 3y squared plus 6y minus 36 equals 0 is translated left 3 units and down 7 units, what is the new equation of the circle in standard form? Well, I can't do anything with this equation until I get rid of this coefficient. So I'm going to divide everything by 3. The reason I'm doing that is because the squared terms have to be 1x squared. They can't be 2x, 3x, 4x, or anything like that, because we won't be able to complete the square if that's the case. So that'll make that x squared and y squared, and it'll reduce these to different numbers. So it's going to be x squared plus 2x plus y squared plus 2y minus 12 equals 0. So let's remind of the steps we got to do to complete the square to get this in standard form, since that's what we're asked for. To get it in standard form, we're going to rearrange. So I'm going to put a blank after the 2x. And for the y squareds, put a blank after the 2y. Move this guy over here and change its sign. So that's going to be 12 plus 2 additional blanks. Remember, to get the numbers in the blanks, we're going to complete the square, which just means to divide the coefficient of x and y by 2 and square it. Well, that's going to be 1 squared, which is 1. And so that's going to be 1 for all of those because that's 2 and those are the same number. So this is actually a pretty quick one since it's got the same number that completes the square. The 12, 1, and 1 are going to add to 14. These are going to factor to two groups of binomials squared. They're going to both start with x. One's going to start with x, one's going to start with y. And remember, the number that comes after the x is half the number that's in front of the coefficient for the x term. So it's going to be plus 1. And it's going to stay plus because it's still in the equation. We don't change the sign yet. We look at that plus, that's going to be plus there. And the same thing for the y's. So that's our new equation, x plus 1 squared plus y plus 1 squared. But we have to address this question. It's got to go left 3 and down 7. So look at the center for a minute. If my center is at -1, -1, because I have to switch the signs, and if I plot the point -1, -1, if I take that left 3, that's going to be -1, -2, -3, -4. So that's going to bring this left to -4. And if I take it down 7, -1, -2, -3, -4, -5, -6, -7, -8. So it's going to take that down to -4 and down to -8. So that new center is going to be -4, -8. So the answer to my question is going to have to incorporate this center. It's going to have the same radius. That's r squared. So its radius is going to be the square root of 14. So my new equation is going to become x plus 4 squared plus y plus 8 squared, and the 14 will remain the same. Okay, let's look at question number 5. Okay, question number 5 says, what is the radius of 8x plus 4y plus x squared equals 10 minus y squared? Well, this question, you have to get the radius using completing the square like we did in the previous problem. It's helpful to have everything to one side. And what I'm going to do is I'm going to go ahead and rearrange now. So the x squared and the 8x, and you're going to have an additional blank. You're going to bring this over here. So it's going to be y squared plus 4y, and a blank to go along with that. Now, because my 10 is already on the right side, we want that to be over here, so we're going to leave that alone. So really, we're just moving the y squared in front of the 4y, the x squared in front of the 8x, and leaving a blank. And of course, after our 10s, we're going to put 2 additional blank numbers as well. So let's go ahead and complete the square. You're going to divide the 8 by 2 and square it. So 8 divided by 2 is 4. 4 squared is 16. Copy it on the left side and the right side. 4 divided by 2 is 2. 2 squared is 4. Again, copy that on the left side and the right side. And let's factor and combine like terms on the right side. So the right side is going to be 10 plus 16 plus 4. Well, that's 26 plus 4, which is 30. The left side is going to group again to 2 binomials squared. So this will be x, and that's a plus, and half of 8 is 4 squared. This is going to be y plus half of 4 is 2 squared equals 30. And so your center is going to be the opposite of these signs, so negative 4, negative 2. And your radius is the square root of 30, which you can calculate if you want to. It's going to be about 5 point something. But the question wants another radius, so the radius would be the square root of 30. All right, question 6 says, given the circumference of a circle is 60 pi, find the area of a 105-degree sector of the circle. Well, we got to start by knowing what the circumference formula is. So the circumference of a circle is 2 pi r. You need to know that formula. And you need to be able to get the radius from that. So go ahead and set 60 pi equal to that. Cancel the pi's. And divide by 2, and your radius is going to be 30. Now we need the radius because it says find the area of a 105-degree sector of this circle. Well, the area formula of a circle is pi r squared. And if I have a degree sector, I have to do degree over 360. So I need to plug my 30 in for the radius. And my degree is given, that's 105. So we're going to substitute that in, and we'll have to do that one in the calculator. So we're going to get that's going to be approximately equal to 824.67. It doesn't give me a unit, so just be units squared. So 824.67 is your area. Okay, question 7. Write the general equation of a circle with center 2, negative 1 and circumference of 12 pi. Well, let's start with the circumference. Just like the last problem, we can get the radius. Set it equal to 2 pi r. Cancel out the pi's. R is going to be 6. Now the formula for we can get the general equation, but we have to get the standard form first. So the standard form is where we switch the signs and square the radius. So it's going to be x minus 2 squared plus y plus 1 squared equals 6 squared, which is 36. Now we got to multiply that out to get it in the general. So general is going to be x minus 2 squared, y plus 1 squared equals 36. So that's going to be x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 36. And we want to rearrange, so I'm going to do x squared plus y squared. Put the x's and y's first, the squares first, and then we'll do the x terms and the y terms alone. Combine these numbers, so that's going to be plus 5. And the last thing we want to do is we want to subtract the 36 from the 5. So that's going to give me 5 minus 36, which is negative 31. So my final answer will be x squared plus y squared minus 4x plus 2y minus 31 is equal to 0. So that's your general form. Okay, question number 8. There is a circular cabinet in the dining room. Looking in from another room at point A, over here, you estimate that you see an arc of the cabinet of about 100 degrees. So this arc right here from B to C, along the minor part of it, is 100 degrees. What is the measure of angle A formed by the tangents to this cabinet? So in order to get the major arc, since there's only 2 arcs here, and all the arcs in a circle do add to 360, we're going to do 360 minus 100. Don't double the 100, do 360 minus 100, and that'll get you 260. Now there's a formula we got to know for this one, and that is the angle, the outside angle is equal to 1/2, we say big arc minus little arc. And so I'm going to plug in 260 and 100 into my formula. That's going to give me 160. And half of 160, half of 16 is 8, so half of 160 is 80 degrees. Okay, let's look at number 9. All right, question number 9. In the diagram of circle O, the ratio of arc BC to arc AB is 3 to 1, meaning BC is 3 times as big as AB. So I know that BC would be 3 times as big as AB. So I don't know what the degree is, but if I had a common x value, then this number would be 3 times that number. So I put an x in front of them. Now what you have to realize is that's a diameter. So that means this is going to be 180 degrees. And the reason it's 180 degrees is because, well, it's half around the circle, and halfway around the circle is 360 degrees divided by 2. So I can get x first by combining these and setting them equal to 180. Um, 180 divided by 4 is going to be 45. So if I substitute the 45 back into x, I get 45 degrees for arc AB. And 3 times 45 is going to be 135. Okay, so now we can answer the question. It says, what is the measure of angle ACB? ACB is down here at the vertex C. Now that angle is an inscribed angle, and it opens up to the arc that's 45 degrees. So that angle is going to be 45 degrees divided by 2, which is 22.5 degrees. You could get all 3 angles in this triangle if you wanted to. You could get this angle by doing 135 divided by 2. And that's going to give 67.5. And you could get this angle by doing 180 divided by 2, which is 90. And if you did your math right, they should all add to 180. So the angle we want down here at C is 22.5 degrees, half of the 45. All right, on question 10, this is a big one here. So we have a lot of angles to be able to solve. We're going to start with first getting the arcs around the circle. So we have arc SN is 60 degrees. We have arc QS, that's going to be X. We have arc QP, that's X plus 40. And then finally we have arc PN, that's 2X minus 16. That's your biggest one. But that represents all the arcs in the circle. So we can add all these arcs together to equal 360. So we're going to start with that equation. We're going to say X plus 40 plus 2X minus 16 plus 60. Set that equal to 360. Solve for X. So X plus 2X is 4X. 60 and 40 is 100. Minus 16 would be 84. Subtract the 84. Let's see, 360 minus 84 is 276. And then divide by 4. And X is going to give you 276 divided by 4, which is 69. So once I have the value of X, I'm going to go ahead and get the remainder of the arcs because I only have the 60-degree one. So, of course, the X value is going to be 69 here. This is going to be 69 plus 40, which is 109. And this will be 2 times 69 minus 16. And I got 122 for that arc. So now that we got all 4 of the arcs, we're set to get all the angles. So let's start. We don't have to necessarily go in order of the angles, but I'm going to start with angle 1 in this case. So angle 1, that's an exterior angle, and so that's related to the 2 arcs it intercepts. So it's going to intercept the arc at 60 degrees on the side closest to it and 122 degrees on the side furthest away. So I can get that angle by doing 1/2 big arc is 122, minus little arc, which is 60. 122 minus 60 is 62, so half of 62 is going to be 31. Okay, so the measure of angle 1 is 31 degrees. I'll go ahead and write that in there. We may be able to just go in order if that's easier. So let's look at angle 2. Angle 2 is actually opening up. It's kind of hard to see angle 2, so we might come back to it if you want, but angle 2 is basically opening up to these 2 arcs. It's the 60 and 69. So you can do 60 plus 69 and then divide that by 2. I'm going to come back to that one just because that's kind of hard to see. So angle 3, that's an inscribed angle. That's going to open up toward this arc, and that angle, this arc is double that angle. So angle 3 is going to be 109 divided by 2. That's going to be 54.5 degrees. So the measure of angle 3 is 109 divided by 2, which is 54.5. Let's look at angle 4. So angle 4 is inscribed toward this arc here on the other side. That's 60-degree arc, so the angle 4 is going to be half of 60. So the measure of angle 4 is 60 divided by 2, which is 30. All right, the measure of angle 5, that's inscribed to the 69-degree arc, so we can do 69 divided by 2. Well, that's going to be 34.5. Okay, the measure of angle 6, that's inscribed to the 122-degree arc. So I can get angle 6 by dividing 122 by 2. And that's going to give you 61. All right, the measure of angle 7, that's inscribed to the 60-degree arc. So I'm going to go ahead and divide 60 by 2. And that'll give you 30. I'm going to skip 9, 10, 11, 8, 9, 10, and 11 for a minute. I'm going to go right ahead to number 12. That's another inscribed angle. 12 opens up to the 109, just the same way as the 3 opens up to the 19. You know, those are going to be the same measure, actually, since they're both inscribed to that arc. So the measure of angle 12, going out of order here, is going to be 109 divided by 2, which again is 54.5. So notice that 12 and 3 are going to be the same measures, just like there's a couple other ones. That these two 30s both open up to the 60-degree arc. So we got pretty much everything but angle 2 and the interior angles. So there's a couple different ways you can get the interior angles. You know, you can cheat. It's not really cheating. You can use triangles to get those. If you add the 30 and the 54.5 and subtract from 180, you can get angle 8. You can do these with the 61, 34.5 to get angle 11. Or you can use the arc plus arc formula. So if I look at angle 8, I know that the two arcs that these interior angles intercept, 69 and 122, I can add those together and divide by 2. So the measure of angle 8 is, it's 1/2 arc plus arc, 122 to plus 69. And 122 plus 69 is 191. Half of 191 is 95.5. Now look at guys, you could do that with triangles too. So I could, you know, you can see my work for that, but I could also do 180 minus 54.5 minus 30, and there's another way to get your 95.5 that way. So however you want to do it is fine. Now you can get angle 11, any two angles that form a line, they add the 180. So you can do 180 minus 95.5 to get 84.5. You could also do 180 minus the 61 and the 34.5 to get 84.5. Or you could also do 60 plus 109 and divide that by 2. So the measure of angle 9 is 60 plus 109 divided by 2, or 1/2 60 plus 109, usually the formula I use. So 60 plus 109 is 169 divided by 2, 84.5. So I like this one just because there's a lot of options as far as what, you know, how you can go about getting those angles. But either way, you get 84.5 for those. Angles that are across from each other are vertical angles, they're congruent. So that means angle 10 is going to be 95.5. And the measure of angle 11 is also 84.5 degrees. And so that leaves us with angle 2. Now you can get angle 2, I know there's a lot going on here. You can get angle 2 by using the two angles in this triangle. So I could do 180 minus 31 minus 84.5. And that's going to give me 64.5. I could also do it by doing half of this arc. Now the arc that it intercepts is actually a combination of two arcs. It's a 60 and a 69. So if you do 60 plus 69 and divide that by 2, there's another way to get 64.5. So you got a lot of different options, but there they all are. Let me zoom out so you can see all the work that went along with that. That's by far the longest one on here. So, take it all in, pause it, whatever you need to do.